Welcome to Chapter 8 on Electrical and Communications Requirements. We're mainly going to be talking about electrical during this Part 1 and Part 2. So I want to get started. Hopefully you've read the chapter. But we're going to be talking a little bit about renewable energy and non-renewable energy first. Kind of the principles of electricity you can see here. Electricity constitutes a form of energy itself that occurs naturally only in unusable forms such as lightning and other static discharges or in natural Elec cells, which cause corrosions. The primary problem in the utilization of electric energy is that unlike fuels or even heat, electricity can't be stored and therefore must be generated and utilized in the same instance. Electricity flowing in a conductor is called a current, which is measured amperes, abbreviated amp or amps, or simply A. When current is used in an equation and is usually represented by the letter I. Current is a measure of flow and as such would correspond to water flow in a hydraulic system. The analogy is not complete. However, because in the hydraulic system the velocity of water flow varies, whereas in the electricity system the velocity is constant and may be considered instantaneous, hence need to utilize the electric energy the instant it is produced. So a lot of times trying to understand why we use electricity, it's a little bit different. Electrical requirements. Some requirements are found in the IBC Code Chapter 27, which hopefully you'll look through and you'll notice it's very short. And you'll know electricians look at the NEC, which is a part of NPFA 70. It's the main electrical code referred to in the United States. It also references other NFPA standards within the text. Now, as I said, the International Code Council has created the ICC-EC, which is the International Code Council Electrical Code. It began in 2006. And it's been adopted and reinforced throughout the United States. There are different standards organizations, and some of these we have referenced and talked about. Remember, these are standards to make sure that electricians, products, other items meet these particular standards, okay? So that anything that is produced or installed has to meet these requirements. There's the American National Standards of Institute, the ANSI, the National Electrical Manufacturers Association, NEMA, the Underwriter Laboratories, UL, and you see a lot of lamps and stuff that have this underneath. Provide supplement designs, installation procedures, and develop standards for the fixtures themselves, as well as provide particular testing and labeling procedures for electrical and communication requirement. As a designer now, you're rarely going to reference the NEC, but as an interior designer, you're generally going to be responsible for determining the location and types of outlets, the types of fixtures, equipment, appliances used in a project. You're going to be specifying those kind of things. In some cases, you will need to coordinate the location of equipment in the rooms. When a project requires substantial electrical work, an electrical engineer is required to design the electrical system. Small projects such as residential homes, tenant finish outs, or spaces do not require the services of an engineer, but a licensed electrical contractor will know the codes and a lot of times review what you have written or what you have drawn or specified. As a designer, as we said, generally is responsible for determining the outlets, but you've got to, of course, make sure that you work with either an engineer or an electrical contractor. let's talk a little bit about components of electricity. There is a switchboard. This is the main electrical panel that distributes the electricity from the utility service connection to the rest of the building. In that switchboard, normally you've got to have, it's got 3 feet deep by 30 inches wide, clear floor space in front of that panel. And it has to be fire rated. And a lot of times you have to have ventilation to control the heat, because sometimes there's heat buildup in a panel. This is very true when it comes to a commercial facility. So what we've got to do is you always have to make sure you have that room in front of the panel or the switchboard. Here's some examples of what they look like. You will see to the left, this is a large panel room that's used in a commercial situation. And then there may be some smaller switch panels that are used that you see in the other diagrams. So we're saying that you have to have 3 feet in front, 30 inches wide to each side, however side the panels are, so that someone could be able to get away if they're working on electricity or the panels, so they will not stay there or, as some people say, fry in front of the panel itself. Another term that I want you to be is the box. You're going to see it's a wired device that's used to contain wires, where the wires are terminated at the end. They connect to other wires, switches, or outlets. They could be sometimes referenced as a junction box, so that means the wires are stored, the end of the wires are stored within this box. And this is where wires may be joined together to go into a certain appliance or an oven or other items. But this is the box, and you're going to see, of course, this is showing a plastic one here, but those, of course, remember, have to have certain standards and they have to be fire rated. Then you have a cable. A cable is kind of a conductor consisting of 2 or more wires.
Okay, I found this on the web.
So 2 or more wires combined in the same protective sheathing and insulated to keep the wires from touching. So you can see the example that's touching going to the outlet itself, how the 2 wires, those are considered a conductor. A circuit, that's the path of electrical current that circles from the electrical source to the component, like outlet to fixtures, and back to the source. So you will see, of course, from the panel, which we talked about, a number here on the bottom right hand corner. You can see where it comes in, and from the panel then it goes to a switch, or it may go to a ceiling fan. A number of circuits are used within the panel, okay, and each circuit, of course, ends up supporting so many types of fixtures. So you may only have 6 light fixtures that go to one circuit. Okay, so electrician, that's what we're looking at to try to figure out how many amps or the flow go into that one circuit. A branch circuit supplies electricity to a number of components or outlets. This is a circuit breaker. You see in the bottom left, this is what I was talking about, that so many circuits in there have the amps or whatever usually written on them, may produce and only be able to go to 4 or 5 outlets, or they go to 4 or 5 light fixtures. And so those are considered, and then you see how many circuits you may have in a panel box. And so when you're looking at this, you don't want to overload, because if you overload a circuit, fault occurs, and so therefore it trips. And sometimes you have homes where somebody's using the blow dryer or whatever, and it trips the breaker, and you have to go in and switch it. But you'll notice when someone is designing a home, you will find that the contractor, or you will find that the electrical engineer always plans for extra circuits that can be installed later if need be. That's why a lot of times in older homes, you find that you don't have enough outlets, you don't have enough of this, and sometimes, of course, they can trip if you try to put too many on one circuit. So it's a safety device that opens and breaks the circuit to stop the flow of electricity when an overload or fault occurs. Now, an arc fault circuit interpreters, which is an AFCI, that's what it's talking about, a device that disconnects the electrical power to the circuit when it detects an unexpected electrical surge. When you get too much on it, it will trip it. And so it's showing here, we have our outlet on the right, and it's showing the arc fault circuit breaker will trip. Alright, I want you to read Chapter 8 in the textbook and Chapter 27 in the IBC code book. I hope this helps you a little bit understand. And now go to Part 2.